All right. Sorry. Good morning, ladies and gentlemen. Yes, it looks like our audio is there, so we're good to go. So, good morning to all of you. Remember what we're working on? We're working on solving equations here, ladies and gentlemen. And I think, yeah, that's what I wanted to remember to do is remind you guys here. If I go to my web page here, if it could load. Okay, slow internet access on campus down here in the basement. You guys aren't 227, you're 241. So remember, I said I was going to fix, and I did. I was going to fix this solving trig equations. So if you guys want to invest in some time here to look over additional examples as we go through the section, I think it's still loading. So, okay, let's refresh this because it looks like it was in the cache. And it should be fixed. There we go. So it's spread out, ladies and gentlemen, a bit more. And I still got to fix that. It's kind of weird. I don't know what's going on there. All right, I'll have to get home. So what we worked on really was the single angles. Okay, so here's some videos of solving trig equations with single angles.
Weird, not quite sure what's going on.
You guys don't know exactly what that means yet, but it's there. I also have, ladies and gentlemen, the additional solving trig equations like with algebra, those with identities, and so on. Don't know what that is. Don't know what that is, ladies and gentlemen. It's a bit odd. Anyway, so ladies and gentlemen, there you go. This is what I'm saying. You do have additional resources and you have a lecture. So you have more resources here for how to solve these trig equations, ladies and gentlemen. Additional resources. And you might say, wow, there you guys go. Anyway. All right. Additional resources is what I'm saying right here on that page. So I'm going to actually put this in your, in the comment section. So, enjoy, ladies and gentlemen, enjoy. All right, now let's go back to what we were doing here. If I can find the iPad. There we go, iPad. Now, what I want to talk about here to go through, just in case, what to do in the case that they ask you. These are all problems we did yesterday. But what does it mean if, for example, they say find all solutions? Because if you look at your homework in this section, you might have said, oh my God, what do they mean by finding all solutions? Well, let's take a look at this first one here, by the way. And if I said to you, we got to find all solutions for that. What does that mean? Well, go about solving this in the way you already have. It means solve for sine by using algebra, right? So you subtract 1 from both sides. Is that right? Then you get 2 sine is what? -1. And you divide both sides now by 2. And now you get sine is -1/2. This is sine is what? Is negative. And then at this point now, you get the reference angle. Is that true? Because you want the positive angle. Right? You guys okay with that? Isn't that what you did before? And then, from my memory, we create the what? You create your right triangle now, right? We're going to try to find that reference angle by definition of sine. What's the definition of sine? Do you guys remember? Isn't it opposite over hypotenuse. So this is 1 and this is 2. So at this point, I'll say to you, things that we did yesterday, right? What's your special triangle? If that's 1 and that's 2, isn't that the square root of 3? Right? You guys okay with that? So you have a special triangle there. What is the angle? Anybody know what that is? Was that a 30-degree angle? Good job. You guys know that. It's pi over what? 6. Is that right? Okay, ladies and gentlemen, what do you guys think? Now, you're going to say to me, but what do you do with this information? Because this is for the reference angle. What do we know here? Sine is what? Negative. We got to know what quadrant sine is negative here. Okay? So, in that case, we got to bring in our all students take calculus again. Right? What quadrants is sine now what? Negative. So you guys were here yesterday, so what do you guys think? Okay. What quadrants is sine negative here? Anybody know? What quadrants? You're looking at it. All students take calculus. So what quadrants is sine negative here? Well, remember, sine has to be negative. Quadrant 3, quadrant 4. Good. Is that right? So sine is negative in these quadrants here. Okay, is that true? Do you guys remember that? But what you found, this 30 degrees, remember, is always the reference quadrant here. Always. So you might say, well, what do I do with that? So what do you guys do with that 30 degrees? You guys remember, this is going to be, that means this is 30 degrees because you're on that unit circle. Shortest distance to from the terminal point, remember that, to the x-axis. Same thing here, and that's not, it's not a unit circle, but you can think of it as a portion of it. That's 30 degrees. So if they gave you the restricted domain, right, this is the idea that this coordinate system is based on you rotating from 0 to 360. Okay, I'll do that again. It's 0 to 360, 0 to 2 pi, 0 to 360, 0 to 2 pi. So you're really finding solutions in the restricted domain from 0, okay, to what? To 2 pi here. And you go, oh, that's pi over 6. It is. So, all right. What would you do yesterday? Do you guys remember? How do I get the angle? How do I get a quadrant 3 angle always? Right? I put x equals pi plus the reference angle. Is that true? Right? Did you guys do that yesterday for quadrant 3? And then quadrant 4, the angle is x equals 2 pi minus that reference angle. All right, is that right? You guys remember that one? Okay, now, ladies and gentlemen, we're on our way now. So you might say if the reference angle here is pi over 6, 30 degrees, we just have to do our arithmetic now, right? So x is going to be, what's the arithmetic here? That's 6 over 6. This will be 6 over 6. So what is the x value? Isn't that 6 pi plus over 6 plus pi over 6? Isn't that 7 pi over 6. And then finally, ladies and gentlemen, over here we get 6 times 2. That's 12 pi over 6 minus 1 pi. So we get 11 pi over 6. Okay. So, ladies and gentlemen, we have solved this particular trig equation here of sine being negative 1/2. Was that what we did yesterday? However, this is over that 0 to 2 pi. This is known, by the way, as particular solutions. You say, what do you mean? These are the particular solutions in the 0 to 2 pi restricted domain. Okay, however, if I use decimals and you go sine is negative 1/2, generally speaking, so I'll do sine is negative 1/2. So we'll say y equal, the sine curve is, well, we have to do it in general. All right, so if you guys take a look at what you're looking at here, generally speaking, because now they're saying, hey, we want you to find what? All solutions in general where there's no restricted domain. So what you guys found for the particular solutions from 0 to 2 pi, you guys should see that right here, right? You got 7 pi over 6, 11 pi over 6. That's where sine is negative 1/2. And ladies and gentlemen, I should say you are looking at really a picture of what? No restriction. What about 5 pi over 6? Negative 5 pi over 6. What about negative pi over 6, right? What about all these other solutions here? Because there's infinitely many. Where do we get these others? You guys see what I'm saying? Where do we get those? And what about all the negative solutions too? Because they told us to find what? All solutions. So you say, okay, that's where we're at here. All right, you guys appreciate the issue? So now they're going to say, find all solutions. In fact, they actually started your homework that way. This is AKA, by the way, to really determine the general solution. And you say, what's the general solution? When there's no restricted domain. They want the general solution here, okay? Now, this is very simple. I'm going to go back. I'm going to erase this here, okay? Let me bring back that ray. This is very simple, ladies and gentlemen. I want you guys to understand a very important idea here, okay? Most of the work is done. You see, you have to get the particular solutions. Here's x1, here's x2. There's two solutions from 0 to 2 pi. So if I said to you, here is that solution 1. This is the x1 solution. You guys agree with that? What they really want to know is, how do you find all the other coterminal solutions? So do you guys remember the meaning of coterminal? What does this mean to be what? Coterminal. What does coterminal mean? You guys remember? That means if I take this ray and I rotate it what? That's one revolution, 360 degrees, or 2 pi radians. That's another angle. That's coterminal. Remember that? So if I said, okay, let's do it again. That's now 2 revolutions for that same terminal point. Rotate it again. 3 revolutions. I can do this how many times? As many times as I want. This is called n revolutions. That's n times 2 pi. Now you say, but what if you go the other direction? Okay, we can subtract what? A full rev. We can subtract another full rev. We can do this all day long. So we can get what's called, again, that very, very important phrase, all the other coterminal solutions, because they share the same terminal point. Now, you say, what does that mean practically? Well, here's what that means. You take the first solution, ladies and gentlemen, and how do we get all the other coterminal solutions? Do you guys remember what you do? You simply do what? Add 2n pi. Okay? What is that? What are you guys looking at when you say add 2n pi? This portion here is what we call the what? This is n revolutions. Where n, does anybody know about n? What does n have to be? What does that statement mean right there? N needs to be a what? You guys know what n is? What does the z stand for? N has to be an integer. So, ladies and gentlemen, here's what's going on here, right? That first general solution here is how we begin to describe every solution, right? This is that general solution. They really want the coterminal solutions. Now, an integer value, in case you guys didn't know, you want to know what integers are. Integers are the numbers -3, -2, -1, 0, 1, 2, 3, and then that goes on forever. These are your integers, ladies and gentlemen. Those are your integers. So you have to plug these things in right in here. Okay, so this is kind of, again, this is where you start with the general solution. There's more that we can do here. I think your book says K, though. But I just want to give you guys that start. Okay, you guys get with me on that? All right, now, what's the other solution here? You say, okay, Mr. Judge, what about this other solution we just found, right? Remember how we just found this solution over here? Come on. Remember this solution, which is 11 pi over 6? We can do the same thing here. I can rotate this counterclockwise, 1 revolution, 2 revolutions, 3 revolutions, 4. I can rotate in the other direction clockwise, 1 rev, 2 revs, 3 revs, and so on. And ladies and gentlemen, you know what we do here? They share the same terminal point because you're finding, again, coterminal solutions here. So we're going to do the same thing. We're going to take the second solution, and what do we do? You guys tell me. What do? We add what? Do you guys know what we add? 2n pi. What does n need to be? Because you want to write that down too. I think your book uses k, but that's okay. What does n need to be? Do you guys know? You say where n is an integer. That's what that means. N is an integer, ladies and gentlemen. So here's the second general solution. That really is code for find all the what? The coterminal solutions. Okay, you guys with me on that here? What do you guys think? Is that easy peasy lemon squeezy? All right, now, but you might say, here's what's going to happen now for people. You're going to say, how can we use this? In some ways you're done. Like in books, sometimes they say, hey, find the general solution. And that's what you're looking at. You're looking at the general solution here. However, if you look at your book, they generated some solutions here, right? So, I mean, Desmos has all these solutions. And you say, where did they come from? How do I get this? What did Desmos do to get these things? Can I share with you guys what Desmos did to get it? Or you guys want to know how they got that? Okay. This is all part of the general solution here. So let's go to the x1 solution here first, right? So to say to you, what did they do? They did a little algebra. I know it's the worst word to use in human existence. Okay, you guys with me on this? Isn't that the first general solution? Okay. So what are you guys looking at? Aren't you looking at a fraction over here plus a whole number? How do I add a fraction with a whole number? How do I do that? Don't they have to have the same denominator? Isn't this arithmetic look familiar? Do you guys see what I'm saying here? Take a look. This is what I'm saying to you guys. 6 and 6. You guys okay with that? So what you're looking at is the sum now of two what? Fractions. Easy peasy lemon squeezy. How do you add two fractions again? They have the same denominator. This is now 7 pi plus what? 12n pi divided by 6, because what did you guys do with the algebra, right? Here's the S portion of the course. Do you guys remember how to do that? What do you get? A plus B over C. Isn't that what we just did? Okay, isn't that the algebra, the S portion? You know, hey, Mr. Judge, what about our supplement? There it is. Little vitamin S. And then now you say, okay, but what do I do now? Do you guys remember something here? You see the numerator? You want to know what you do with that numerator? You factor the numerator. You factor out the greatest common factor. And in fact, you're not just going to factor the numerator, you're going to factor the denominator too. In other words, I want you guys to notice something here. Okay? What is common to both in the numerator here? Don't you have pi and pi? Isn't that common? You know what you could do? Factor out the pi. Remember, factor out the pi. What are you left with if you factor pi out? You're left with 7 plus what? 12n over 6. Is that true? You guys with me on that? You factored out pi. Now, this is gold, ladies and gentlemen. You should be what? Happy to do that. That doesn't look right, but whatever. So what you're looking at here, if I said this to you guys, right? You get pi over 6, 7 plus 12n, just by factoring out pi. And n is an integer. What I just shared with you guys here is, this is known as the sequence form. You got the sequence form of the general solution. Why is this nice? Because if you look in your book, what they do now is they let n be what? Like 0. And if n is 0, you plug in 0 for n, right? Well, what's 12 times 0? Isn't that 0? And what's 0 plus 7? Isn't that 7? So when n is 0, do you guys know what you get? This is what? This is your solution. This is a sequence form. Let n be 1 now. You say, what is that? Well, that's pi over 6 now. And now add what number here? Put a 1. What's 12 times 1? Isn't that 12? What's 12 plus 7? Isn't that 19? So it's 19 pi over 6. What happens when n is 2 now, ladies and gentlemen? What do you have here? You say, well, plug in 2 now for n. Okay, what do you guys get now if I plug in 2? Isn't this 7 plus 24? What's 7 plus 24? Is that 31? So you're going to get 31 pi over what? 6. Okay, but didn't we say integers are also what? What are integers? It's not just these numbers here. Integers are also negative. Is that true? So you might say, what about some of those negative numbers? Like what happens if n happened to be negative 1, right? I don't know, maybe you say x4. You say, what is x4 if n is negative 1? Plug in a negative 1 there. So it's going to be a multiple again of pi over 6. I think you always want to understand that. This gives you multiples of pi over 6. But 7 minus 12 now. What's 7 minus 12? It's negative 5 pi over 6. You can plug in n is negative 2 now. So you say when n is negative 2, what's x to the 5? N is negative 2. What's this? 7 minus 24. What's 7 minus 24? Anyone know what 7 minus 24 is? Is that negative 17? So what you're seeing here is what we call a sequence form, and it helps you generate all the other terms. So if you look at this and you say, is that where decimals got some of these answers? Yes. Okay. If I go back here, where are you decimals? Okay, so I'm going to just say here, 7 pi over 6, 19 pi over 6, 31 pi over 6, right? Some of these answers are what you see here. Negative pi over 6, negative 5 pi over 6. You might say I don't see all of those, negative 13 pi over 6. You only seen some of these here. Where do you think the others came from? Do you guys know where the others came from? You do the same thing for x2. So I'm diving into the weeds here, ladies and gentlemen, for all of this, the great details. Because the other solution, the same thing can happen here. You can write the sequence form. And that actually helps in your arithmetic in the long run, right? You go, what do you mean? What does it help in the long run? Well, in the long run, you're going to have to do this arithmetic anyway to generate solutions. You might as well just write it in the sequence form to begin with. In other words, 6 over 6. Repeat the algebra. 11 pi over 6 plus 12 in pi over 6. Do the algebra. What do you guys do now? Do you guys know what you can do? You can say 11 pi plus 12 n pi. They're all over 6 again because you did this algebra algorithm here. And then what did you do earlier? We factored out the what? Pi, is that right? So you get pi over 6 now, 11 plus what? 2n. And this generates the sequence of solutions. N is an integer. So you're going to get all of those solutions now, ladies and gentlemen, by changing your n value. The integers are what you see here. So again, you might say, okay, can I have, and maybe it's better not even to do subscripts here because now the subscripts are really confusing. Just say x, right? So now I'll say here, okay, what happens? What color do we use? Do we use that blue? Okay, we use blue. So now with the sequence version, if n is 0, what does that mean about x? Pi over 6, plug in 0. What's 2 times 0? Do you guys know what that is? Isn't that 0? So 11 plus 0, isn't that 11? So this is going to be 11 pi over what? 6. Let n be 1. What solutions do you get now? If n is 1, now you say, oh, I changed this n to 1. Doesn't that give me 13? Right? 11 plus 2 times 1. Isn't that 13? So this is going to give you 13 pi over 6. What if n is 2 now? Plug it into the sequence form. These are all multiples of what? Pi over 6. So 2 times 2 is 4 plus 11. What do you get? 15 pi over 6. Can't you do negative numbers as well? Yes. N is negative 1. So let's just plug in negative 1 into the sequence form, and you get, what's 11 minus 2 now? Isn't that 9? So, oh, 9 pi over 6. So now n is 2 here. 11 minus 4. Is that 7? I think it's 7. So, ladies and gentlemen, this is how you generate some of these solutions here when they say find all. Now, you don't really say n is 10, n is 20. You don't go through it that way. But if you look in your book, and all of a sudden they start generating these solutions, you go, where did they get those numbers? Boy, the book just gave me the equation, but they didn't necessarily plug in all of these values here, right? So if you look at your book, because it says find all solutions, well, you're just generating some solutions here. You're looking at them, but this is where Desmos gets them as well. So you should see negative 13 pi over 6, negative 5 pi over 6, negative pi over 6, 7 pi over 6, and so on. You should see 11 pi over 6 and 19 pi over 6. This is where they got them, 23 pi, 31 pi over 6. They got them, ladies and gentlemen, doing what we see here. What do you guys think? Is that easy, or is that... Say, boy, that's involved. It is. It is. That's why I always put additional examples here. And let's go back to another one. What do you guys think? Anybody have any questions on what we just did here? Because I want to go to this one here. Right? How do we do the same thing to find all solutions here? In this example, we're going to find all solutions. This is not going to be, I should say, well, we're going to see the difference. All right, we're going to see the difference here. So if I said to you, how do we do this? Do you guys remember how we do this? What do we do to solve this trig equation? What do we do? You guys remember? You add 1 to both sides and you get what? Square root of 3. You solve for tangent. Is that right? And then what do? So we have to find where tangent is 1 over the square root of 3. So we're going to compare and contrast this situation. This is finding all solutions here. So do you guys remember what you do here? We need the what? Don't we need the reference angle again here? And we draw our right triangle. We're going to find the quadrant 1. This is the reference angle. What's the definition of tangent? Do you guys remember the definition? What's tangent? Is it opposite over what? Adjacent? 1. Square root of 3. Can you guys identify what this might be? What special triangle is this? Anybody know? Isn't this going to be 2? Is that right? So what's your angle for x? You got to go back to that special triangle here. What's that? What's the reference angle going to be? I don't know. 30 degrees again. You go, oh my God, there's that 30 degrees. Okay. Pi over 6. Let's see how this works. But now with what? Tangent. Anybody have any questions on this part, right? What do we bring in? All students take what? Calculus. All students take calculus here, ladies and gentlemen. This is what we bring in here. So let's find it. And we have to remember, tangent is what? Positive. What quadrants is tangent positive now? All students take calculus. Where is tangent positive? Do you guys know? Tangent's positive. Where is it? Yeah, do you know the meaning of alternate state calculus? You guys know? That means all three trig functions are positive, and then where over here? Quadrant 1 and quadrant 3. Thank you, Jonathan. Outstanding. What was the reference angle again? 30 degrees. And you go, okay, well, remember this situation here, right? This is 30 degrees. This is 30 degrees. Didn't we say in quadrant 1, the angle is the reference angle? In other words, x equals what? 30 degrees. That's your first solution. I'm going to keep it blue, I guess, this time. All right? What's the other solution here, right? Remember what you do here. How do we get a quadrant 3 solution? We take x is pi plus the reference. So if my reference is pi over 6, 30 degrees, right? How do we get that second solution? We say, okay, pi plus pi over 6, and what's that going to be here? This is going to be what? 6 over 6. What does that give you? Isn't that 7 pi over 6? Okay, double check. Am I okay with this? All right. Now, ladies and gentlemen, here's the deal. They want you to find what? All solutions. So in other words, that's code for saying what? Take your first solution, which is pi over 6. Take your second solution, which is 7 pi over 6. Now, you might say this to me. Let's go through this exercise because what you have is something important here. Okay? I can say, all right, what if the first solution was, and it really is, pi over 6, right? I want you guys to see this. How do I get the next coterminal if I rotate counterclockwise? Don't I add 2 pi? How do I get the next coterminal? Add another 2 pi, which is now 4 pi. Rotate again, another 2 pi, which is 6 pi. I could do this all day long. In fact, I could go the other way to get the next coterminal, the other way. In other words, if you said, Mr. Judge, I want to just add 2n pi. Is there anything wrong with that? And I'll say, no, there's nothing wrong with that. Okay? There's nothing really wrong with that. And you go, well, I'm going to do the same thing like the first example. I'm going to go now to the second solution here. And to get all other coterminal, I'm going to rotate a full revolution. 2 pi, another integer multiple. 2 pi, that's now 4 pi. Keep doing that. Oh, 3 times 2 pi, go the other direction. Minus 2 pi. Minus 2 pi. I could get all the coterminal solutions. But I'm going to say this to you guys. If you said this, it's not that it's wrong, but I want you to note that this is what you really want to see. If you read the book and you look in back of the book, you might say n is an integer. You might say, Mr. Judge, why do they give you this as the general solution here? Why? What happened to the other solutions and 2n pi? Does anybody know why they give you this? Why is this in back of the book? Anybody know? Because it is. Anybody know what's going on there? 568039. Anybody know? What's the deal? Let me share with you guys what's going on here. They're being more efficient. Remember, this is a terminal point here on that circle, and so is this, right? When you have this situation here, you say, what is your situation? When your solutions are in opposite quadrants, right? You see that first solution? I just have to rotate what? Is that a full revolution? That's only pi. Here, let's do it again. Here's my first solution. Rotate pi 180 degrees, a straight line. There's your second solution. Rotate another pi. There's the solution again. So what am I doing? I can alternate quadrants by a multiple of pi now because they're in opposite quadrants. You say, what if you went the other way? Oh, okay. I'm rotating 180 degrees again. That's pi. This is the second pi. This is the third pi. This is the fourth pi. So this is when you have solutions in opposite quadrants. And that happens with tangent, by the way, and cotangent. You're going to see the solution be take the first one right in here, take this one, and then just add n pi. So you're alternating between quadrant 1 and quadrant 3. That's always what you do when you have opposite what? Quadrant solutions. Now that makes things easier, not harder. So knowing this will make everything a lot easier on you. All right, you guys good with that? So here's the deal. This is what? N is a what? Integer. That's the general solution. So if you look in back of the book, you're going to see this. But I want you guys to note here, because you might say, why? How do they get the sequence of solutions, right? Where did that come from? The sequence solution form. Well, they did the algebra. You go, what algebra? Multiply the top by 6 and the bottom by 6. This is the arithmetic we've been doing from the beginning. All right. And then you said, well, don't you actually do some of that? I wonder if I still have it here as a. No, I don't. But anyway, you guys should know this formula by now, right? You guys know the formula? You get pi plus 6n pi, everything over what? That common denominator. That's why you use the 6, right? And then what did you factor out again? You factor out the pi, and you're now going to have 1 plus 6n. N is an integer value. So you went from the general solution here in back of the book. We got the sequence version, and now you can say n is what? Oh, what happens when n is 0? Plug it in. You know what x is? 1 plus 6 times 0. Is that 1? It's going to be a multiple of that pi over 6 again. You're going to always generate multiples of pi over 6. Do n is 1, because they may say, what's the first 2 or 3 terms? Just change your n value. It's an integer. X is now going to be what? What's 1 plus 6 times 1? Isn't that 7? N is 2 now. Repeat the process. What is x? 1 plus 6 times 2. Isn't that 13? Well, do negative 1. Maybe we want to go the other way. What's 1 plus 6 times negative 1? Isn't that negative 5? So x will be what? So, ladies and gentlemen, they're using n values here to here we're going to get 5 solutions here. Now change n as negative 2 here, right? So we get 1 minus 12. What's 1 minus 12? Is that negative 11? Right? So the point I'm going to make again for you guys is this. You get the general solution. Now, from the general solution, you can change n values there, but you're going to still end up doing this arithmetic right here, ladies and gentlemen. You're going to still do that arithmetic. So sometimes writing the sequence form, and I'll look at your textbook, I think at the end, it says, hey, here's the sequence form, something like that, you know. But anyway, maybe I'm giving you too much information. Maybe this is a calculus. I'm trying to remember where I seen that in your book. But if you're headed to calculus, you know, a lot of times they give answers in what? The sequence form. Because you can very easily generate those solutions. Now remember, what is this? What's the equation here? Tangent is 1 over the square root of 3, right? So if we go to Desmos and we go to tangent now, not sine. Okay. I think it was positive, right? So you say, oh, pi over 6, 7 pi over 6. What's this, 13 pi over 6? You see that sequence? 1 pi over 6, 7 pi over 6, 13 pi over 6. One pi over 6, 7 pi over 6, 13 pi over 6. What about the other way? Where did they get the negative 5 pi over 6, negative 11? Negative 5 pi over 6. So, ladies and gentlemen, there's a negative 11. So I just want to share with you guys here the little details there. This is how they got those solutions. They did the sequence form, or they really just added n, and there it is. What do you guys think? Is that pretty good? Just going back over here. Let's take a look, ladies and gentlemen, of, something like the last one. It's kind of an easy one. You're finding all solutions. Remember, that's kind of how they started all this. But you have to find the particular solution first in the interval of 0 to 2 pi before you ever go to the general solution. And from the general, you can write the sequence. Okay. Try this one here. You say, how do we do sine? You think, is this one easy? Yeah, it is. Add 1. You have to find where sine is 1. Now, remember what I've been doing here. There's no special triangle for these. You guys remember where sine is 1, sine is what? -1, sine is 0. There's no special triangle. You got to go back to the graph here. Okay? Go back to when you guys graph sine. You see, this is a common thing, ladies and gentlemen, finding values here. Remember this largest value. Get back to the intercept. Smallest value. Back up here. Here's x. Here's y. Where is sine 1? Remember the particular solution? Sine is 1 when x is what? Pi over 2. Are you guys okay with that? Okay, 90 degrees. That's from 0 to 2 pi. That's the only place where sine is 1. And now you might say, why are you bringing in the all-student state calculus when we're not even looking at quadrants? But I want to give you guys a picture. Okay, because a picture is worth 1,000 words, right? What's that? What's that angle? That's the solution. Is that true? You guys with me on that? 90 degrees. That's the solution. How do I now get all the other coterminal solutions? Which is your general solution. Does anybody know? How do we do that? Remember? Do you have solutions in opposite quadrants? Say no. There's only one solution. Is that true? So how you get the others, I can rotate what? That's one full revolution. That's 2 pi. Rotate again. Another what? 2 pi. That's 4 pi. Rotate again. 6 pi. Go in the other direction. That's minus 2 pi. This is minus another 2 pi. What am I getting at? What do you guys write down here as the general solution? Do you guys know? You take your particular solution, and now what do? You add what? 2n pi. Good. N is an integer. There it is, ladies and gentlemen. You have only one. So that's kind of what happens for sine. And if you said, well, how do they get the sequence, right? Well, the sequence solution here, again, it's very helpful to generate the sequence. This time, because my denominator is what? 2, right? What do we do there? Multiply the top by 2 and the bottom by 2. We're going to use the algebra here to get the sequence form. So you get now pi over 2 plus what? 4m pi over 2. I factor out, ladies and gentlemen, really pi over 2. And you're left with 1 plus 4n, where n is an what? Integer. So here's your sequence form. Why that's important, I think, is because when you now go back and you say, well, what kind of solutions do we have? Well, let n be 0 again. You get x is what? Pi over 2. Let n be 1. Now that's 1 plus 4, which is what? 5 pi over 2. Let n be 2 now. Okay, plug in 2. 1 plus 4 times 2. Isn't that 1 plus 8, which is 9? Okay. Oh, you want to go the other direction. Negative 1. Plug in negative 1. So it's 1 minus 4. It's negative 3. 1 minus 4. Negative 3 pi over 2. Plug in the other value of a negative 2 now. Let's get rid of that. 1 minus 8. Isn't that negative 7 pi over 2? So when you look in the book and they start listing these solutions, you go, where do they get these values? They just plug values of n in. Remember, this is sine is 1. So if you said sine equals 1 in Desmos, here's what you guys want to do. There is a sine curve. It's right here. Let's get rid of the tangent. And this y value we'll use. We want to make y equal 1. You set the y's equal to each other. And notice what you see here. Okay? You start seeing all solutions. Negative 3 pi over 2, pi over 2. You go, what about over here? Well, that's negative what? 7 pi, negative 3 pi over 2. 5 pi over 2. 9 pi over 2. Isn't that the solutions we were getting here? Nice, ladies and gentlemen. What do you guys think? Is that pretty good? So this is how you find all solutions. And I want to go back to that other question that I had here. So put 4 down. Okay, what about this one here? Two cosine minus 2 equals 0. Square root of 2 equals 0. All right, let's try that one here. Okay. And again, it's find all solutions. Finding all solutions. So, like before, what do you guys do? You have to solve for what? Did you solve for cosine? Add the square root of 2 to both sides. You get now what? 2 cosine equals the square root of 2. Divide both sides by 2 and you get cosine is what? The square root of 2 over 2. Do you guys remember what I said to you guys yesterday? What do you want to replace this with? You guys remember? Isn't that the same as 1 over the square root of 2? Right? So that might be helpful for you to identify what you need to do. Meaning, if we want to find the reference angle, you say, oh, 1 over the square root of 2 now. And we get to use the what? You get to use your special triangle. What's the definition? Adjacent over what? Hypotenuse. 1 square root of 2. I'm going to bring out the red. I always do that for what? What special triangle is this? There's only 2 you have to know. Isn't that the 1, 1 square root of 2? What's your angle, ladies and gentlemen, for 1, 1 square root of 2? What's that angle going to be? It's 45 degrees. Is that true? There's your reference. What? Angle. All right. All students take what? Calculus. We got to find that picture. We got to get rid of all this. Where'd it go? Hey, I added the picture. I'm sure I did. I like adding that picture. I don't know about you guys. You guys like adding that picture in? I think it's kind of clear. So where is cosine what? Positive. What quadrants are cosine positive? Do you guys remember? Anybody know? You're looking at it. Cosine's positive where? Isn't it quadrant 1? And quadrant what? 4. Is that true? What was your reference angle again? 45 degrees. Right? So what's our first solution? Do you guys know? The first solution is simply pi over 4 because it's in quadrant 1. Remember, your reference angle is the angle in quadrant 1. So that's the answer. But what about quadrant 4? Because that's where cosine's positive. You guys remember? Isn't that going to be, what is this? 2 pi minus the reference. Do you guys remember that? So if my reference is pi over 4, what's that second solution? What's the second solution? What's that going to be? 7 pi over 4. Right? Isn't that kind of all the stuff we did yesterday? Now I want you guys to know when they want the general solution, because they want you to find all solutions now. All of them. You're going to now have 2 of these values. Is that right? What do I mean by that? First solution is pi over 4. So if I take that ray, like I've been doing here, right? We take the ray. What's the deal? There's my first solution. How do I get the next solution? Is it going to be, are they in opposite quadrants like the path? No. So you're going to have to do what? Rotate what? 1 full revolution to get all the other coterminal. 1 full rev. 1 full rev. You can go in the opposite direction. 1 full rev. 1 full rev. These are not in opposite quadrants, ladies and gentlemen. The point being, I have to add what? 2n pi. I don't add n pi because they're not in opposite quadrants. What about the other situation. Same thing. If you have your solution here, rotate what? One full rev. Rotate one full rev. Rotate one full rev. Go in the other direction to get all the other coterminal solutions. This is not like the prior example. So you're going to have to add what here? 2n pi. So if you look in back of the book, what do you guys think you're going to see? You're going to see that. Okay, you're going to see that in back of the book. But then you go, what about the sequence version? Because what if they start listing all those values? Where do they get them? Well, you always want to say n is a what? Integer. They get them by changing the n values, right? So I'm going to just do this for you, a little bit of the algebra so you guys can get used to that, because I think even in the book, they do ask you at some point, right? See that 4? What do you guys do to get the sequence version? Multiply the top by 4 and the bottom by 4. Is that right? And you end up getting pi over 4 plus 8n pi over 4. Is that right? You guys okay with that? Now, factor out the multiple of what? Pi over 4. Factor that multiple out. You're going to get pi over 4 times 1 plus what? 8n. So we have the sequence form, n as an integer, and they're all multiples of pi over 4 now. And you can generate every other value that you need. This is kind of what they want you to do. And again, you say, what about the other one? Well, it's going to be a different sequence form, but it's the exact same algebra. Okay, you go, what do you mean? Well, you're going to add the fraction with the whole number. So you're going to use that denominator again of 4 to get the common denominator from algebra or even arithmetic. So we get the 7 pi over 4, ladies and gentlemen, plus the 8n pi over 4. Oops, not that. Be sure at the end of the day to factor out what? The pi over 4. So this will be pi over 4 times 7 plus what? 8n. N is an integer. So, ladies and gentlemen, as you guys can see, you should still now be able to start to do some what? Homework. What do you guys think? Are you guys able to start to do some of those homework questions? When do you guys want to try this out? Yeah, exactly. And then let me remind you guys, right? If you need to see extra examples, let's say you do. You go, Mr. Judge, I can't get enough of examples. Where can I see them? Well, you guys have a video here. Is that true? You got a video here. You got a video here. You got a video here. You got a video. Well, it's really it's really going to be what? These two, actually, I guess. Because next time we have to talk about multiple angles and, how to use an identity and so on. So, we'll do those things. But ladies and gentlemen, yeah, we got some algebra versions, how to use an identity as well. So you do have resources here for that. Okay, does that kind of make some sense? All right. If I were you, I'd get started. Don't procrastinate. And we'll see you guys when? What's today? Thursday? Okay, we'll see you guys on Monday, but I'm not going to have office hours today in case people were interested in that because I have a medical procedure later on this afternoon. Don't worry, it's nothing major. It's just routine old man stuff. Old man stuff. All right, so I'll see you guys later. Take care.